Let's take a couple of simple examples. Here's an example, and it's a rational function because it's a ratio of polynomials. The polynomial on the top is x cubed plus x. The polynomial on the bottom is x to the 7th plus x to the 5. Let me ask you, is this even or odd?
Well, since all the powers are odd, that would make the resulting function odd, so I would say it's an odd function.
Well, that was only true for polynomials. This is not a polynomial, but rather a ratio of them. So the numerator is odd and the denominator is odd. But as we'll see later, if you have an odd function over an odd function, the result is even. So this is actually even, but let's explain this more basically. And let's explain this by showing that this rational function is actually a function of x squared. So what we can do is we can look at the function we started with, and then just divide the numerator by x and the denominator by x, and we get x squared plus 1 over x to the 6 plus x to the 4. And now then, let's just express this x to the 6 as x squared all cubed, and x to the 4 as x squared all squared. Then this is clearly a function of x squared. Hence, it's even. Let's take another example. Here in this example is a little bit more exotic. F of x is a natural logarithm, ln, of 1 plus x over 1 minus x. So we could ask, is that function even or odd? Well, the first thing that we should do when you have a non-trivial function like this is we should try to figure out, well, what's the domain? Well, the domain of this function actually is the open interval from -1 to 1. And that is because what we need is we need 1 plus x over 1 minus x to be greater than 0 for ln 1 plus x over 1 minus x to exist. Because you can only take the logarithm of a positive number. 1 plus x over 1 minus x being greater than 0, this translates to x being in -1, 1. Okay, so in particular, if you're outside this region, so if you're at less than or equal to -1, so say you're less than -1, then what's going to happen is this denominator here is going to be positive and the numerator is going to be negative, so it's going to be a negative number. You can verify this by taking cases that this has to be true. All right. What this means is we only have to look at x in -1 and 1. So for such an x, f of minus x, so we just substitute this in the equation. So in place of x, we substitute minus x. Okay, so then from this original formula, we have 1 plus minus x. And on the bottom, we have 1 minus minus x. Okay, well, this 1 plus minus x just becomes immediately 1 minus x. And the denominator 1 minus minus x becomes 1 plus x. Then, if you switch these two things around, that's equivalent to saying, well, this is equal to then ln of 1 over 1 plus x over 1 minus x. Okay, so it's 1 over this ratio, like that. Okay, so this is equal to that, but we want this denominator up above, but this is just by log rules that we've learned before. So if we have 1 over this, we can just bring a negative sign out in front and bring this all up, except for there's a mistake here. Sorry about that. This should be plus, and this should be minus, and this is just by this logarithmic rule. Okay, so we have what we had back. So this then is just our f of x. And so we have f of minus x is equal to minus f of x. So this function is odd. Thank you.